Showtime is right. Mark your own. Here we go. My favorite student, good old Ann. This is a pretty good indication of about 90% of the questions that you're going to see on your test. Some will be multiple choice, some will be written. It'll be about half and half, give or take. What word did, Christina, what word did I bold font in number 1? Okay, and what are they wanting me to find? They're wanting me to find neither A nor B. This is a bit of a tricky one. I threw a mini curveball, and I did that on purpose on number 1 just to say to you, you know what? Sometimes the first question on the test isn't the easiest. I will scatter the level of difficulty. I do that on purpose to prepare you for post-secondary, those of you that are going to post-secondary, which is most of you. You can't always assume number 1 is a gimme, is a freebie. Neither A nor B, that means not A or B. It's going to end up being what we're talking about, by the way, is this section in here, if we talked about a Venn diagram. What word did I bold font? Mutually exclusive means no overlap. It means actually what I just drew here should be two completely separate circles if I was using a Venn diagram approach. And if this was A and this was B, we would say 4/7 and 1/7. The other way that you could think about this, and Brooke, this is what I did with you, I said we can find this. Because what does OR mean? It's going to be the probability of A plus the probability of B. Technically minus the overlap, but we said when it's mutually exclusive, there is no overlap because it means it can't happen at the same time. So OR is going to be 4/7 and 1/7. Now, if you suck at fractions, use the fraction button. And I'd rather you didn't suck at fractions, but I'd less rather you get this wrong. I've seen some kids say, oh, that's 4/49. No, that would be multiplying. 4/7 and 1/7 is 5/7. So the probability of it not occurring is going to be 1 takeaway 5/7. The probability of neither, which is the probability of not, is 1 takeaway 5/7, except I need a common denominator, or you can use your fraction button. The common denominator is going to be 7/7 takeaway 5/7. The answer to number 1 for 1 mark is 2/7. So if I gave you a question like this, I could either, if the simpler version would have simply been to say, what's the probability of A or B occurring, which would be added together. Here I added the twist. I said, what's the probability of them not occurring, which means find the probability of one or the other occurring, and then go the complement 1 minus to find the probability of them not occurring. Number 2, Justin, can you read me number 2, please?
2 cards.
How many cards?
2 cards.
Probably a tree. Or I could do this with a bucket. Keep reading. The second sentence.
So are
This,
selected.
the second sentence
What is
after the period. There you go.
That one card is a queen and the other card is a jack.
Now, this is also a curveball. This was me being sneaky. Did this say what's the probability that the first card is a queen and the second card is a jack? Or did this say what's the probability that one is a queen and one is a jack?
One is a queen and one is a jack.
Yeah, I didn't say anything about order here.
Yeah.
So here's what this really means. The answer to this is going to be the probability that you got a queen on the first, a jack on the second, or the probability that you got a jack on the first, a queen on the second. Technically, 2 trees. Or the other way that you could do this is you could say this is going to be a bucket with queen, jack, and others, and you could say there's 4 queens, there's 4 jacks, 44 others. 1, 1, none. 4 choose 1, 4 choose 1, 44 choose none over 52 choose 2. Okay. Either of those works. And the reason is, Sean, I was sneaky. If I had said absolutely a tree would be if I had said what's the probability that the first card is a queen and the second card is a jack, and your tree branch would be queen 1, jack 1, and you would fill in the appropriate fractions. Here, since they didn't give me a specific order, I got to take into account both possibilities. I can do it this way, or I can actually say, you know what? How many queens are there? 4 out of 52. And how many jacks are there? 4 out of only 51 cards left, because I've already picked a queen. Or how many jacks are there? 4 out of 52. And how many queens are there? 4 out of 51. Either of those methods works. So you could either go 4 choose 1 and 4 choose 1 and 44 choose none all over 52 choose 2, or the first method. I'm going to use the first method because I happen to have it set up here. 4 out of 52 and 4 out of 51, or 4 out of 52 and 4 out of 51. Or as the shortcut, I could have done this times 2 because they're the same number twice. Regardless, I get B. Yep. Please put it on top of block B. Yep. Okay. If I use the choose method, I'll just do it because some of you are kind of wondering. Where is it on this option? Arrow sideways, prop. 4 choose 1 and 4 choose 1 and 44 choose none. By the way, that's really 4 times 1 over 52 choose 2. Actually, no, because if I hit times, it will assume it's on the top. I can be a little sloppy if stuff is on the top. It'll assume it's there. I really have to be fussy when I got more than one thing on the bottom. Probably a good habit would have been to put it in brackets, but I'm pretty sure, I hope I'm going to be, yeah, 8 out of 660. I'm okay. Yep. Number 3. Kyla, my angel, as you're yawning, in number 3, do you see percentages, yes or no? Do you see 2 categories, peas and carrots? Yeah, probably a Venn. I don't know yet, but probably a Venn diagram. Did they tell you either and, the overlap, both, or neither? Did they tell you either one of those 2? Look at the question. Did they tell you the and overlap both, or did they tell you neither? Did they tell you any one of those 2? Psst, look up. Did they tell you and both, or did they? Yes, definitely a Venn diagram. There is a way to do this with the formulas. Venn diagram works best. My Venn diagram is going to look as follows. Peas, carrots. When you're doing a Venn diagram, you want to start with the overlap. If they didn't tell you the overlap, put an X there. Did they tell me the overlap? Nod, Kyla. What's the and? What's the overlap? What number is going to go in the middle? 11. Or as a, well, you know what? I'll do it as a percent. 11. Sure. What percent like peas? 18. Am I going to put an 18 there? No. Why not? What do I already have in the letter P already? 11. So what am I going to put that only like peas? Yes. What percent only like carrots? So I know 50% like carrots. I'm not going to put a 50 there. What am I going to put here, folks? 39. What do all the percentages have to add to? 100. Right now I have 7, 11, and 39. What's going to be outside the 2 circles? 40, 43? Now I can answer the question. The question says, what percent of high school seniors only like peas? What else could I ask if I did a part A, B, C, and D? Hey, what percent only like carrots? What percent only like carrots? 39. What percent don't like their vegetables? 43. What percent like some vegetables? 57. 7 or 11 or 39. Because that's some vegetables. Some of them like both, but I didn't distinguish. Question? This is important, and I'm going to be willing to pause. I booked this whole class. Question or no? What number is right there? Read it to me. I can't put an 18 there because I've already got an 11 inside the P circle. If I put an 18 there, I'd be saying that 18 plus 11, I'd be saying 29% like P's. What do those two add to? That's the 18% that like P's. What do those two add to? That's the 50% that like carrots. Okay, I have to subtract to find what goes, if I know the middle, the overlap, I've already got some in there already, I have to subtract to find what's left over. Number 4. Ellen, when you're done yawning, can you read, please? How many cards? Bucket. Cards, bucket. And looking at this question, it looks like we have red cards, black face cards, and others. Yeah, that's why I underlined the word black face cards, Tiffany. And others. How many red cards are there? You need to know this. How many red cards are there? I'll even do that in red. Uh-huh. How many first of all, just how many face cards grand total are there in the deck? 12, because it's 3 per suit times 4, 12. How many of those are black? Half of them. So how many black face cards are there, Tiffany? 6, you say? How many cards are left over? Whatever 52 take away 26 take away 6 is. I think 20. Okay, I've got my bucket set up. How many red cards do I want to choose? 3. How many black face cards, Tiffany, do I want to choose? 2. How many of the others do I want to choose? None. So I think it's going to be 26, choose 3 of those, and 6, choose 2 of those, and 20, choose none of those. Over from 52 cards, choose 5. And remember, our built-in error check, Jordan, is front plus front plus front equals front, back plus back plus back equals back. Which is why I always do write that, even though it doesn't make a difference to the actual calculation. I love the symmetry. It does give me a lovely built-in error check. 26, choose 3, and 6, choose 2, and 20, choose none. Over 52, choose 5. I get, I didn't ask for a fraction this time. I get D. D. Number 5. Number 5. 2 key ideas in number 5. Foster, what word did I underline? What does independence mean? It means the odds will never change. The odds are always going to be 60%, 60%, 60%, 60%, 60%, 60%. Unlike for a card question where every time you pick a card, there's one less card in the deck, and so now the odds have just changed. The second key concept, Foster, is, what did I underline? How many attempts? How many attempts? Not a tree. Independence, not a tree. Now, 5 attempts would be either a bucket or binomial. It would be a bucket, like number 4, if it's not independent. The fact that it's independent, this is going to be a binomial probability distribution. This is going to be either 5 choose 2, 0.6 2 goals, 0.4, 3 misses. Or BPD, your guys is X2, num trial 5.6, I think is the order that you type it on your calculator. Give me a second. Let me crunch the numbers, and then I'll take questions. Stat, dist, binom, not cumulative. 2, 5.6. Whoa. Oh, it says at least, Mr. Dueck. The third word, Mr. Dueck, you should have underlined is that. Mr. Dueck made a mistake, and he didn't do it on purpose. He was just being careless, which means actually you can't use that method. And really what I need to do, at least 2, that means... Right? Unfortunately, my calculator won't do that directly. What my calculator will do is, and then I can go 1 minus that, which is going to be 1 minus the cumulative distribution of 1, 5 shots, 0.6. Mr. Dueck, that was terrible. Distribution, cumulative distribution, 1, 5 shots, 0.6, and then I've learned on my calculator, you folks, if you hit enter, it just stores that in your answer button. On mine, I have learned that I can go save result in list number 1, enter, and now when I go here, I can go 1, takeaway. I did this before, Mr. Dueck. Where's my list button? List 1. Oh! Okay. What's the answer? B? It's going to be 1 takeaway 0.0870. 1 takeaway 0.08704. Is that right? Yeah. 1 minus 0.08704. B. You're going to find by the 3rd or 4th decimal we might be a bit off. Question. Yep. So 2 or 3 or 4 or 5, my calculator can't do. Okay, what's the opposite of 2 or more? That's where the 1 comes from. I've got to go 1 minus 1 or less is going to give me 2 or more. And that's why there's a 1 there, not a 2 there. If you put a 2 there, what you found was 3 or more, the opposite of which is 2 or less. I like that question. I like that question. I like that question. Number 6, a fair die and a fair coin are tossed. What's the probability the tail is showing together with a 5? Tail, 1/2, and a 5, 1/6. B. Nothing fancy there. There's 2 events. I multiplied because and means multiply. Together with is another word for and. Yep. Did you get the same answer? Yep. Because a tree is is the way we do and. But that one, because it was only 2 events that I knew, I said I can survive without the tree. Yep. Picking 2 balls, tree. So let's see. We can go white on the first, black on the first, white on the second, black on the second, white on the second, black on the second. How many whites are there? 3 out of 10, 7 out of 10. Down this branch, we picked a white, so we have 2 out of 9, but there's still 7 black out of 9. Down this branch, we picked a black. We have 3 out of 9, or 6 out of 9. There's my tree. This question wants both balls to be the same color. That's that branch or that branch. Or means add. 3 out of 10 and 2 out of 9. Or 7 out of 10 and 6 out of 9. 3 out of 10 and 2 out of 9. Or 7 out of 10 and 6 out of 9. Oh, I did a plus. That's a typo. Times, right? You get 8 out of 15? A. B. Sorry, B. 8. B. 8. According to a research company, 70% of telephone subscribers have an answering machine. If a telemarketing campaign contacts 200 telephone subscribers, how many telephone subscribers? Do I want to do a 200-level tree? No. So this is either bucket or binomial. This is not bucket because I don't think the odds ever change. Every time that you phone, there's always a 75% chance, or sorry, a 70% chance that they have an answering machine. This wants 150 or more. The probability of my calculator can't do. What's the opposite of 150 or more? 149, or it's going to be 1 minus the probability of 149. In fact, this is the same as we just did 2 questions ago. I just made the numbers bigger to show you where they might actually use this in industry. It's going to be 1 minus the BCD of 149, 200.7. 149, 200.7. I get one. It's going to be 1 minus 0.93045. 1 minus 0.93045. So it's either A or D. 1 minus 0.93045. Looks like D. Looks like A. Sorry, A. Right? That's close. 0.069. There's about a 7% chance that more than 150 will have an answering machine. Number 9. Probability of B given A. That's going to be the probability of B and A divided by the probability of A. What's the probability of B and A? That one. 2 out of 11. What's the probability of A? That one. 1, 2, 3, 4, 5. Because there's 5 dots in the A circle. And if you go 2 fraction 11 divided by 5 fraction 11, I think you're going to find the answer is C. Okay? So for conditional, we said it's always both of them and divided by the given one. Turn the page. 12 cards. How many cards? 12, bucket. They want aces, kings, and 6 other cards. So let's see here. It's going to be aces, kings, and others. There's 4 aces, 4 kings, and 52, take away 4, 44 others. And we want how many aces? 4. How many kings? 2. How many others? 6. So it's going to be 4 choose 4, 4 choose 2, 44 choose 6, all over 52 choose 12. A. Got to be A. Number 11. Kyla, my angel, do you see percentages? Do you see two categories, sunglasses, sunscreen? I think probably a Venn diagram. The only issue here is they didn't give me the and. This is going to be a trickier one. Watch. The other reason this is tricky is both sunglasses and sunscreen both begin with an S. So do you mind? I'm going to use G for glasses and S for sunscreen. Otherwise, I don't know how I'm going to keep this straight. Sorry? Oh, they gave you the 18%. Ah, they did give you the and. This isn't too bad then. So, sorry, there's an 18 there. Brooke, my joy, what's in the middle there? So I've already got 18 in each. Now it says 47% wear sunglasses. I've already got 18% in the sunglasses circle. So what's going to go right here? Whatever 47 take away 18 is, 29 is going to go right there. Oh, they did not give me the sunscreen number, but what's this 46? Who do not. They gave me that. Hey, what do the percentages have to add to? So I'm going to go 29 plus 18 plus 46, 100. Well, I could do that in my head, I guess. 100 minus 93. You know what? Right there must be 7. The answer is not 7. Look at the sunscreen circle. Grand total, how many are in the sunscreen circle? Not 7, because there's also an 18 in there already. Those are both sunscreeners. Okay? Here's a sample space with some dice. I typed it up for you. How nice was that? And it gives me some events. In English, what does that mean? What does mutually exclusive mean in English? Can't happen at the same time. So I'm not using any math here. I'm just going to look at the events and I'm going to use my common sense and I'm going to say, can they both occur at the same time? Let's see. Can A and B occur at the same time? Can you add to 6 and have the first dice be a 4? Yeah, that would be rolling a 4 and then rolling a what? A 2. So, you know what? These are not, A and B are not mutual. Oh, you know what? Why don't I look at the answers instead? I was going to go through all the options up there. B and D. Can the first dice be a 4 and the second dice be a 5? Is that possible? Yeah? So they're not mutually exclusive. That one's wrong. B and C. Can the first dice be a 4 and them add to 9? Yeah, as long as the second dice is a what? A 5. That is possible, not mutually exclusive. Let's look at A and C. Can the sum be 6 and at the same time the sum be 9? No! Got to be that. Okay? No math there, just common sense. But you have to know what the word mutually exclusive means. It means can't happen at the same time. Come to the written section. Number 1. Kyla, my angel, in number 1, do you see percentages? Do you see 2 categories? I think a Venn diagram is going to work here. This was the one that I was thinking about that did not. Oh, it does give you the and again. Good gosh. Dueck. You were easy. So we have television, stereo. By the way, what's the fancy word for when the and is empty, when they both can't happen at the same time? What's the fancy word for that? Mutually exclusive, okay? It tells me that 48%, you know what, change colors, Mr. Dueck, so it's a little easier to stands out a bit more. 48% have both. If 88% have a TV, and I've already got 48%, then this right here must be 40. And they gave me 2% have neither. Hey, what do these have to add to? 100? What goes right here then? Now I've got it set up. Now I can answer the question. What's the probability that a randomly selected home has only a TV or only a stereo, but not both? See it? Them and them, but not both. By the way, 1 mark for the Venn diagram and then 1 mark for the answer. And I would take 50% or I would take 0.5. I'd take whether you made it decimals or percentages. I don't care. Sean, can you read to me B?
Given.
What was that?
Given.
Conditional. Ready? Given what? Keep reading.
That a randomly selected home in this province has a television.
Stop. Given television.
Yeah.
Find what?
What is the probability, rounded to the nearest percent, that this home does not have a stereo?
Not S. Right? Which is, I find this formula very difficult to work with, which is why I've told you once you have this written, it's always going to be both of those and divided by the T, the second one. It's going to be not stereo and TV divided by TV. Now TV I can get, TV is 88, the 40 and the 48. What about not a stereo, but also still a TV? Which of those is not owning a stereo, but also still owning a TV? Which number is that?
40.
The 40. Do you own a TV right there? Do you not own a stereo right there? Yep. That's the overlap. And that was a tricky one. I did that on purpose because nice Venn diagram. So 40 over 48, or in lowest terms, divide by 4, divide by 4. 10 over 20, actually divide by 8, divide by 8. 5 over 11. I would give you a half mark if I saw that you had translated the formula correctly, and then a half mark for the answer. I don't care whether you reduced or not. Did anybody decimalize it? Okay. I think as a decimal, I think it's 0.555 repeating, or 54 or 54. I can't remember. Number 2. How many cards? 5. Bucket, not tree. Yeah, technically 50, but how many cards are we choosing? Okay. It wants at most 2 aces, which means 0 or 1 or 2 aces. That's what at most means. The opposite of that is 3 or 4. I guess I could go 1 minus 3 or 4. Or I could add these. You know what? Going 1 minus 3 or 4 is still going to require me to do a bucket twice and go 1 minus. This is going to require me to do 3 buckets. I don't know that there's a huge time savings using the complements. So I'm just going to add them up. But it's definitely a bucket. My bucket is going to look like this. Aces, not aces. 4, 48. For no aces, 0, and what? How many of the 48 am I going to choose? 5. So for no aces, it would be 4, choose 0, and 48, choose 5. Or 1 ace, 4 non-aces, right? 4, choose 1, and 48, choose 4. Or 2 aces, which is a okay poker hand now. 3 generic cards. 4, choose 2, and 48, choose 3. And all of these would be over from 52 cards. Right, Erica? 52 cards. Choose how many cards, Erica? 5. On the top, is there plus signs? Now I do have to use brackets on the top if it's separated by plus signs. So it's going to be bracket for oh, geez. Russian, Fressen, where is it? Option. There, I wish it would remember this on mine, but it doesn't. Yours it does, I think. Bracket 4, choose 0, and 48, choose 5, or 4, choose 1, and 48, choose 4, or 4, choose 2, and 48, choose 3, close bracket. All over 52, choose 5. Is it 0.9982? Yep. And I did say to 4 decimal places. If you made it a fraction, I won't take marks off. Will it do a fraction? You know what? My calculator won't even convert it. So it must be a pretty yucky fraction. 0.9982. So if you got 0.9982, you get 2 out of 2. Otherwise, I would probably go something like this. 1 mark if I saw the top, a half mark if I saw the bottom, a half mark for the answer. This helping? I hope. Okay, turn the page. Tiffany, can you read to me what I underlined in bold font there, please? A red ace. There was 2 words there, really? Okay, just, making a point. How many cards are we choosing, Tiffany? I could do bucket. I think I'm going to do tree, especially because here they're talking about the second card, which makes me suggest I want to track what's going on a little bit more. So the probability that the second card is a red ace depends. You know what it depends on? Whether the first card is a red ace. So my tree is going to look like this. Red ace on the first card. Or not. Red ace on the second. Or not. Red ace on the second. Whoop, I did a not there. Or not. How many aces are there in the deck, grand total? 4. How many of those are red? 2. Okay, so if I'm setting up my branch, it's going to be 2 out of 52, and I guess 50 out of 52. Down this branch, you picked a red ace. How many red aces are left? 1 out of 51, and 50 out of 51. Down this branch, you got a whatever. How many red aces are left? 2 out of 51. And 49 out of 51. Double check, adds to 1, adds to 1, adds to 1. My built-in error check is there. Now, Rachel, joy of my heart, what's this question wanting me to find? Can you read me the second sentence? What is the probability what?
As a fraction lowest term.
Gotcha.
Second card is red.
You know what? The branches that end with a red ace 2 are that branch or that branch. It's going to be that or that. It's going to be multiply down, add across. It's going to be 2 out of 52 and 1 out of 51, or 50 out of 52 and 2 out of 51. It's going to be 2 fraction 52 and 1 fraction 51, or 50 fraction 52 and 2 fraction 51. Double check, did I type that right? 2 out of 52 and 1 out of 51, or 50 out of 52, and looks good. Oh, and as a fraction in lowest terms, I guess the answer is, you got a 1 in 26 chance. Didn't see that coming, but okay. In terms of part marks, if you got this right, of course, always 2 out of 2. Otherwise, probably I would have given you 1 mark for the tree. a half mark for that, and a half mark for the answer. Problem is, if you got the tree wrong, you're getting everything else. This was a tricky one, by the way. Don't kid yourself. I tried to make this quiz tough. In fact, I tried to make this quiz slightly, maybe even significantly tougher than the test. I wanted to beat you up a little bit, partly because I was grumpy that so many of you hadn't done quiz number 2. I like number 4, I like number 4, I like number 4. Number 4 is a nice question. Looks like we're picking a bag. And then picking a marble. White, black. I was going to use B for black, but because I used B for the bag and I didn't want to accidentally get them confused, I'm going to go white and not white. That's just me being really paranoid so that I don't read my writing wrong later. White, not white. Now, if I didn't have this, so right now it says a die is rolled. If I didn't do that, it would be a 1/2 and a 1/2, because the odds of you picking either bag is 50-50. It's 1/2, 1/2. But that was boring, so in this case, I made up the dice question. I think on your test, I give you a question very similar to this, but I think I nuked the rolling the dice part, in which case it would just be put a 1/2 there, put a 1/2 there, because you got a 1 and 2 chance of picking either bag. But meanwhile, this one is going to be 2 out of 6, 4 out of 6. Okay, now let's go look at bag A. How many are white? 7 out of 12, 5 out of 12. Bag B, 8 out of 17, 9 out of 17. Okay, A. Find the probability of getting a black marble. That's that branch or that branch. And again, I used not white instead of the letter B because I didn't want to confuse it with the B in the bag. So the probability of black, which in my tree is not white, that's going to be 2 out of 6 and 7, Mr. Dueck. 5 out of 12 or 4 out of 6 and 9 out of 17. That's a yucky fraction, but okay. 2 out of 6 and 5 out of 12 or 4 out of 6 and 9 out of 17. Do you get 301 out of 612? Kind of a yucky, sorry, I was making up bad. That 17 being prime gave me yucky fraction numbers. If you get that, 2 out of 2. Otherwise, I would probably give you 1 mark for the proper tree, half mark for that, and a half mark for the answer. And then, oh yeah, given. Good. Conditional. I like this question too. Let's see, that's going to be given that we got a black, which I've used not white for. Find the probability it came from A. Jordan, you going to make it?
Yeah.
Okay. Jordan, my friend, how do I do a given?
You use that A and not one.
And conveniently, I just did not white. That was 301 over 612. That was nice of them. A and not white. A and not white. 2 out of 6 and 5 out of 12. Two out of 6 and 5 out of 12. I'll just do the top first. This is going to be 5 out of 36 as a fraction divided by 301 out of 612. How do I divide by a fraction? It's flip it and multiply, but we're being very pragmatic. I got a fraction button. Do you get 85 out of 301? Again, if you got that right, 2 out of 2. Otherwise, I would probably go something like this. half mark for translating. Half mark for that. Oh, heck, you know what? I'd probably give you also a half mark for the bottom, and then a half mark for the answer. And there's your lovely 2 marks. That makes sense? Then I would turn the page. Oh, Ellen, look at you! All-star. Mr. Dueck, did you change that question after you found out that I made All-star last week? Maybe. Sorry, couldn't resist. Ellen's hitting 3-point. Look at that, at a blistering 43%. Wow, that's pretty good. Find the probability that she hits exactly 7 of her next 10 shots. Of her next how many shots? I don't think we're doing a tree here. This is either bucket or binomial. You know what? I don't think the odds change. If you're hitting it 43%, each time you shoot it, it's going to be a 43%. This is binomial. So it can either be... Let me sleep this for 10 more minutes. This is something we may get to if I can, but I might not because I want to make sure I go over this quiz. You can either do it the long way. From 10, choose 7. 43%, 7 makes. What's the complement of 43%? 0.57, and she'll miss 3. Or you can go 7 out of 10, 43% chance of it going in. You know what? I'll do it the long way just because I happen to have this menu open, but you could certainly do it the short way. 10, choose 7 times 0.43 to the 7th times 0.57 to the 3rd. Do you get 0.06040? Did you get that? 0.0604? How many decimal places did I say to go to? 4? Yeah. 0.0604. You know what? 43%, even though that's really good shooting, going 7 for 10, even among the pros, does not happen very often. Okay? Someone's phone's going off. I wonder whose phone that would be. Let's just power this thing off completely. You see, when it receives a text message, it sends out an electromagnetic field which interferes with the magnets in the speakers, inducing a current. Anyways, it does. Who's in Physics 12 with me? You'll actually, towards the end of the year, learn how that works and why that works. Oh, at least 6 of her next 10. That means 6 or... You know what? That's going to be 1 minus the probability of 5 or fewer. 1 minus the BCD of 510.43. .43, and I get 0.7793, so 1 minus 0.7793. 7793, yep. 1 minus 0.7793. Well, you've got a 22% chance, Ellen, about a 1 in 5 chance that you might go 6 or 7 or 8. So if this was accurate, let's suppose you're playing a season with 100 games, probably 4 or 5 times during the year, if you were this good a shooter, you would have a night, and people would say, oh, she's hot on fire, she's hitting everything. You know what? It's actually just randomness. It's been proven time and time again that although athletes will believe that they're on a streak, that they're a streak shooter, you can prove each time it happens and exactly matches the random pattern that it should. It's just that athletes don't want to believe that. They like to think that they have control over everything. What did I make this? 1 mark for the first one. 2 marks, I would probably go something like this. 1 mark if you clued in on that. Half mark for the numbers. Half mark for the answer. How many more questions? Is this the last one? Woohoo! Good, I'm going to finish in time. This is the one that I hope I might save your life. As a matter of fact, did you guys read the Province today? Today in the Province, there was a guy up in Kelowna who was told that he had tested positive for colon cancer. And he doesn't have it. And for 2 days, Like he bought life insurance, he met with his wife, he told his children, he met with his mom and dad, he told everybody he had tested positive for colon cancer because he had tested positive on the test. Didn't get a second test. So he went to see his doctor, and his doctor redid the test and interpreted the results and said, nah, your levels are slightly elevated, but you're well within the norm still. So this still does happen. Read the province. It was page 2 or 3 of the province today. I think right now, him and his wife were kind of ticked off at the way it was done because it was done with a phone call and an email. Probably could have been handled better. You're not going to sue. The issue is it's a brand new test, and it's a good thing that it's overly sensitive. You'd rather get a false positive than get a false negative. That the big one you don't want is, yeah, you had it, we didn't catch it, so sorry, we could have treated you 4 months ago, but better make your will. That's what you want to avoid, and if that does mean, it's terrible, but if that does mean a few more people have 2 or 3 days of horrible anxiety, that's a better trade-off, and that's why I'm telling you guys, don't freak, get a second test. Get a third test, then freak. So here's what we have. You have the disease or you don't, because you have the disease when you walk into the office. Once you walk into the office, you either test positive or not, positive or not. What's the probability that you have the disease? The test is 92% accurate. That means if you have the disease, you'll test positive 92% of the time, you'll test negative 8% of the time. If you don't have the disease, what should you test? If you don't have the disease, what should you test? So you should test negative 92% of the time, and positive 8% of the time. 1 mark for the tree. Then, what's the probability that you test positive? Probability of positive, that's going to be, you know what? This branch or this branch. It's going to be 0.02 times 0.98 or, no, sorry, 0.92, Mr. Dueck. Read the numbers correctly. Or 0.98 times 0.08. Is that right? That branch or that branch. That's right. Hopefully you're starting to see why the tree is such a nice visual way to keep track of everything. I've seen this taught without trees where you just track everything in your head. And it can be done. It's a little ugly. Do you get 0.0968? Wow. You've actually got a 91% chance of not having it. I'd take those odds almost any day. 0.0968. I would give you 1 mark for that, 1 mark for that, and 1 mark for the tree. Number 7. Given. Given that you test positive, what's the probability you have the disease? Which is... And thankfully, I just did P. It's 0.0968. D and P. D and P. D 0.02 and 0.02 and 0.92. This is the more interesting one. I was this question here. Probably you test positive. You're not very likely to test positive already. And if you test positive, what's the probability that you have it? Let's find out. It's going to be 0.02 times 0.92 divided by, I can use my answer button because I have that stored on my calculator right now. The probability that you actually have the disease is 0.1901. You only have a 19% chance of having it even though you've tested positive. You've got an 81% chance of being perfectly healthy. So yeah, if you read the province today, there was a story. They didn't go into the mathematics of it, but I'm willing to bet it was something along these lines. Can you give yourself a score at the top, please, out of, count 'em, holy smokes, 31. Okay. However, would you like these to study from? So you're going to hand these in the day of the test. Okay? Yep.
Can you just go downstairs
Right there. Someone's not paying attention? I don't know. I totally care. Yeah, sure. You put all the fractions over 1. Show me in a second. I'll look. First of all, any lawyering with me or any... Okay, let me pause the video. So you can hand this quiz in on Friday, but what else is due Friday? This huge Mudgeness review. This will take you a couple hours, so I hope you've started. It'll take you a while. Justin, what's your question? Okay. And I told you which questions I liked, and there is a full handwritten solution key online, and there are 2 answer keys up here. So you have the remaining 10 minutes to work on.